Next presentation is Murtaza Hasan. Okay. So, Dr. Murtaza Hasan, please introduce yourself briefly and make a presentation. Yeah, thank you.
Good morning, everybody. Respected Ajendra Singh sir, Indramani sir, Kote sir, dear students. Myself, Murtaza Hasan, I am principal scientist at Indian Agriculture Research Institute, and there is a center there, Center for Protected Cultivation Technology, in which we have, for the last about 23 years, we have been working on various forms of protected cultivation. But the latest, for the last 5 or 6 years, we have been working only on smart urban farming technology. So what we are working, what are the projects we are dealing, I shall be talking about. And as told by Dr. Syed sir, I have made exactly 15 slides. So, okay, this is the farm in which I am working. You can see from the area. This is about 25-acre farms, and you can see all the structure that you are seeing. This is all the, I should say that engineering effort, that different structures, mainly the protected structures are there, each with different area, different types of ventilation, different types of crops. So we have a team in which I was fortunate to work with Indramani sir. Then there are a team of engineers, then horticulturists, plant protections, and with very good projects that I shall share with you. So this is my title that what I have given: Plant Factory Based Smart Urban Fabric. Next slide. So what I shall be talking about to you, that I shall be telling about what is the present status and future prospect of this plant factory based urban farming. And then what is the greenhouse soilless cultivation technology? What are its newest forms of protected cultivation like soilless, hydroponics, aeroponics? So once you have this core technology, and then as an engineer, our next effort is to build the designs and all, then go for the or adopt latest technology of automation, sensors, controllers, IoT, all AI and ML. So first infrastructure, and then you have to go for this technology. What are the advantages and challenges? Because these are new things for our country, and some technological and policy issues. Next slide. See now, if we see what is the relevance of smart urban farming in the coming days, you can see that the agriculture global issues, that decrease in agriculture population, arable area, we have the population increasing, and then the arable land area is decreasing. Then you have decrease in biodiversity and green space. And we know that nowadays there are two types of stress that is prevailing. One is what we call abiotic stress, that is, that all sort of weather abnormality. We have extreme summer, extreme winter, everything is extreme now. So in that things, how to go for the agriculture. Then the present generation also needs the quality of life. We need now, especially after the post-COVID, in less space, lots of nutrition vegetables. This is the things now coming up. There is a trend of growing herbs crops. Everyone are growing herbs, vegetables, fruits. These are the crops that is required by the present generation. So how to grow it? What are the things that as an engineer we can do it? Now, on the other hand, that is also especially in and around peri-urban areas, in Marathwada area also, that I was supposed to ask the question with Indramani sir, that in this area now everywhere water is shortage. So shortage of water, fossil fuel and biomass. So these are, you can see so many complex things are there. And one thing that is missing in this slide, that is the biotic stress also. So we are working with the team of scientists in which they are saying that very complex diseases are coming in the plant also. So you can imagine when we are working at IRI and facing lots of problems, what will happen to the poor farmers? So in these scenarios, that is now the present, everywhere it is there, every part of the world, there is a relevance of smart urban farming. Next. So in the, especially what I want to tell you, that this is a new thing, that is once you go for the plant production systems, you can grow the crops in open field, you can grow the crop in greenhouses, and now there is a new thing that you can grow the crop inside everywhere. Suppose you are sitting here, now you want to grow the plants here, you want to grow something in your drawing room, in your office now, that you can do it now. So indoor systems are there. So what is there? You have a controlled environment, and then in the open field, of course, it is uncontrolled. There is a latest concept that is called PFL, that is the Plant Factory in Artificial Life. This system is very popular in many advanced countries. So what I wanted to do, that in those big countries, there are spaces. So in our country, there is not much space. Everyone will ask that we have already so much open field, so many greenhouses also there, then why we need another area? So what we thought that plant factory in artificial light, can we grow the plant factory inside the existing protected structure? So this is the new concept that we are working. We are using the plant factory concept, but not with demanding another area, because that is not possible in our country. So how to have the plant factory concept even in open field and even in the greenhouse? So this is the model that we are working. So growing, so this you can see that the plant factory system. One, this plant factory system, that is the greenhouse base. So you have the existing greenhouse, it's already there. Now, in almost every part of the country, greenhouse is there. Now, how to make this greenhouse most efficient in terms of space especially. So you can see how this type of infrastructure we have created. See, this is a, in the left side picture, there is a 1000 square meter climate controlled greenhouse space there. What we have made 6 layers hydroponics based system. This we call plant factory system. Now in this system, what will happen that in normally in 1000 square meter greenhouse, you can grow about 2000 to 4000 plants maximum. If you grow the big crops like tomato and capsicum, it is 2000 to 4000 per square meter. But in this type of system, we can grow more than 10,000 plants in the same area. But we have to take care as engineer, what is the design, that what are the crops to be grown, what should be the spacing. So we can see that the spacing between each layer, it should be minimum 40 centimeter, 45 centimeter. Now what will happen that you can see in the picture, there are 2 types of the, one is flat bed. Okay, so flat bed is there, it is like this. So if you grow the crop here, this part will get not sufficient light. So you have to go for artificial light management. Then what is the solution? You go type A type bed frame. You can see in the left side picture, you make your frame like A side. So when there is a frame, you have the very good uniform distribution of light. So in this type of system, first of all, you have to make the infrastructure, decide what to the crops to be grown. Then the next important thing is that now you go for its fertigation. How every crop at every place should get right amount of water and nutrient. That is also the most important thing. Yesterday we talked about irrigation scheduling. Here it is fertigation scheduling. So it is very important that all the crops should grow all the nutrients at right times. Now, for this, now lots of efforts are being made. What types of pumps are being used, and now with the latest technologies, we can use the smart sensors. Very smart peristaltic pumps are there that can be used for very precise application of water and nutrients. So this type of, that's for developing the infrastructures, and then we are using here lots of sensors, whatever the available sensors of nutrients management, moisture management, and then go for its automation, then artificial intelligence based aspects, some IoT application. So these are the things there. On the right side, you can see, please go back. On the right side, the same thing is indoor plant factory system. So when it is indoor, you have some office-like structures on the rooftop, then you have to totally depend on artificial light. So now artificial light technology has developed a lot, and you will be surprised that this artificial light, now what we are doing, our PhD and master students are working, and especially I would like to share with all the students here, light is very important, and it has different spectrum. Now what we are studying, that for which plant at which stage which spectrum is important. So we have found that our research that this spectrum not only affects the amount of production, it also affects the light, the qualitative parts like vitamin C, antioxidant, if there is anything is there. All these have direct relation with the light. We have published some recently very good paper in the Nature by my PhD student, in which we have found that the light spectrum like red light, blue light, how in which amount, RB ratio, and in which quantity, it totally affects everything, vitamin C, antioxidant, everywhere it is affected. So light is going to be now very important, and fortunately the LED light, smart LED light, is very energy efficient. It is now very cheap also available. So, but no, we cannot use directly light here. Which spectrum to be used? What should be the quantum, and then R by B ratio? Everything can be made available. So this is another new thing. So you have the interaction of light, water, and nutrient for any crop. It can be for open field also. But here, especially inside this system, we found that light, water, and nutrient interaction is very important, and then we are taking the projects accordingly for this type of crop. crop. So in the coming days, these things will be very important. Next. So what we found that why it is sustainable in the terms of it is very water and energy efficient. Let me give you one example. If we grow 1 kg of lettuce crop in the drip irrigation in the open field, it takes about what we have found about that in the open field also about 40 to 50 liter water for 1 kg of lettuce. Same crop, if you will grow with hydroponics inside these things, it will take only about 4 to 5 liter. So there is a drastic reduction that about 10 times, 90% saving of water. So water is, that coming days, it is very important. So that's why these technologies are very water efficient. Then precision farming, of course, because all things you have to apply at right time, right amount. It comes under controlled environment agriculture. If you are growing inside, you have to take care of these things. Next, as I already told you that in our country, what is the present status? In our country, what is the status? See, in our country, farmers are also doing urban farming nowadays, but mostly they are doing in the form of greenhouse, soilless cultivation, hydroponics, and aeroponics. There is a one term missing here that now we are how to integrate. We are already using the fish in this system that is called aquaponics. Recently, we have got one National Agriculture Science Fund related project in which we are the lead center and Central Institute of Fishery Education is my partner. So there now my job is to integrate fish also here. And then fish-based nutrient excreta, they will be the nutrient for this plant. So how to optimize these things? So these things are very important in coming days. Everyone wants to grow good crops, healthy crops inside their home also. And if some fish will be available also, that will be very good for the common citizen. So this type of model we are working. Presently, we are affected that total area covered is approximately 5,000 hectares. Farmers are mostly growing vegetables, flowers, and I told you, like crops like nursery crops, then other fruits are there, then lots of herbs are being grown. And then there are two types of system. One is called, this is open loop type system. Open loop, it means that there is no recycling. So recycling is also very important. That it is difficult, but the growers do not do it normally. So all the water and nutrients are being recycled. If it is recycled, then it is called closed loop system, but its management is slightly difficult. And then you have to take care of the salt management, which that is the most important thing. And what is we found that in our country now, there is the technology is in primitive state, it lacks technological thrust. So we are working with not only infrastructure, but with automation, with sensors, controllers, and IoT. Next. What are the sensors you require? You see so many sensors are required for smart urban farming. There is no soil here, so you do not require soil. You require soilless moisture sensor. Then fertigation sensors. See, fertigation sensors is very important. So for all the nutrient, we require precise sensors here, and these sensors are very costly. So we are working with 2 German institutes and then 5 sensors, that is NPK, calcium, and magnesium. We have made these sensors, and then that prototype we are trying to bring from Germany and then standardize it. So that is very important. There are some sensors are available, but these sensors are very costly. So individual sensors now required for individual nutrient management. Then disease monitoring sensors, again, it is very costly, not normally available. Nutrient deficiency sensor is available. Fruit quality sensors, some sensors are available. So you can imagine that so many sensors we require in coming days. And that's why now that ICR is now doing project with many industries like and then other institutes also like IIT, IIIT, CDAC, because they have the expertise to develop the sensors. So we in the coming days, there is a lot of requirement of sensors for growers and farmers in our country. Next. See now, please continue. It will okay. So this is there are many projects I am executing, but this is one of the projects I would like to show you that how. Next, please. Next. Yes, next. Yeah, please stop. So this is this project. I should say that it was started at the time of when Nirmani sir was here, and he worked a lot of hard work with us, and many good projects we found with the help of, and sir was our team leader at IARI. And then these all projects are now, sir, working, and it was your great leadership and your stewardship that these projects formed at that time. So you see now this type of project in which we have 2 German institutes are there. And then you can see here that one Indian industry, Barton and Breeze, and when German industry, Bruckner is there. So this type of projects now, they are funding in which the 2 academic institutes also, sir was telling that how academic industry and they are working. Okay, so this is how this type of project is there, and very lucrative funding by BST, and then we have developed very good infrastructure with this type of project. Next. So yeah, as I was telling that we have developed a team, and this team consists of mostly the masters and PhD students. A very good team, teen urban farming that we have developed at IRI. All our partners are there, and then they are working very closely in this type of system. Next. So these are you can see that these are all the latest infrastructure. You can come sometimes and see that IoT and sensor operated vertical farming we have developed. Next. What are the future challenges from the Indian context? See, we need indigenous and cost-effective models. These models are, let me tell you, very, very costly. So everyone will ask how we will do, how it is suitable for Indian country. Then integrated approach, engineers and plant experts, linkage of industry and institutions. We need, as I told you, sensors. So far, there is no center of excellence in vertical farming that we are trying. Exposure, demonstration, and training to different target groups for us also, and for every target group, student, everyone require this type of training. And then government policies, now there it is on protected cultivation. It should be brought into vertical farming and smart urban farming. And that is next. These are some technical bulletins that we have developed for, and these are available free. Next. These are all very good publications, and these are all available free on Google. You can download it from it. Finally, this is my final slide. Conclusion. See now, this type of farming is the practice of sustainable food production in vertically layers, and then it can be integrated in any other side. As I told you, yields are also very high with very less water consumption. Only 8 to 10% of normal water consumption. Main benefit, we can go for IoT-based systems controls, AI, ML, all things you can apply. Higher quality, we have shown that we got very good quality crops and yield obtained with the sensors. So sensor and all these things also help in increasing the quality also. Suitable in post-COVID area, and of course now this protected cultivation things we need to strengthen these things. Last slide. Thank you very much.
Any quick question to Dr. Murtaza? Yes.
So, what crop is most suitable in Indian condition? Is anybody taken it to a commercial stage? Vertical, specifically on vertical farm.
Yeah, in vertical farming, we have found initially that green leafy vegetables is very suitable. And let me tell you, green leafy vegetables initially we thought that only like lettuce, spinach, and at present you'll be surprised there are around 150 green leafy vegetables. 150. There are many out there. Lettuce itself is about 10 to 20 times. So this, you can grow anything here, but green leafy gives very good results.
Anybody has gone commercial?
Yeah, many places now commercial farms are there.
In India?
Yeah, India also. Thank you.
Thank you very much, Dr. Murtaza. Where is your photographer? Thank you.
Sure.